First one, problems. A straight wire carries a current of 3 ampere. Calculate the magnitude of magnetic field at a point 10 centimeter away from the wire. Straight wire carrying current, infinitely long straight conductor carrying current using Biot-Savart law we have studied. So in that, we have to calculate magnetic induction B. So B is equal to mu naught I by 2 pi R. That is the formula. The data, current 3 ampere, distance 10 centimeter. Calculate B is equal to mu naught is 4 pi into 10 power minus 7. 3 ampere by 2 pi into 10 into 10 power minus 2. 2 times 6. 10 power minus 1, numerator plus 1. So 10 power minus 6 Tesla is the unit of magnetic induction. Second problem, a vertical wire in which current is flowing produces a neutral point with the earth magnetic field at a distance of 10 centimeter from the wire. What is the current? If BH is 1.8 into 10 power minus 4 Tesla. Same concept, ma. We have to calculate the current. Mu naught I by 2 pi R. So I will be B into 2 pi R by mu naught. Magnetic induction 1.8 into 10 power minus 4, 2 pi. The distance R is 10 centimeter by mu naught 4 pi into 10 power minus 7. 2 times. Simplify, you are getting the answer 90. 1.8 by 2 is 0.9. 10 power minus 4 minus 6 minus 5. This is plus 7. Minus 5 plus 7 is 10 power 2. So it will become 90 ampere. 90 ampere is extraordinary high value. I is equal to 90 ampere. For the problem we are doing, but basic concept, 1 coulomb of charge means extraordinary high force. Coulomb's inverse square law. So 90 ampere is very, very high value of current. Third problem. In the Bohr-Height model of hydrogen, electron revolves around the nucleus in a circular path of radius 5.11 into 10 power minus 1 meter at a frequency of 6.8 into 10 power 15 hertz. What is the magnetic field set up at the center of the coil? Circular coil carrying current, point at the center. Again, Biot-Savart law application. Circular coil along the axis we have seen. When the point is at the center, B is equal to mu naught Ni by 2R, 2A, 2X radius. Number of turns they have not mentioned here. So we can very well write mu naught I by 2R. Okay. They have given radius R 5.11 10 power minus 11. Frequency 6.8 into 10 power 15 hertz. Sir, frequency, there is no formula. Then what we have to write frequency? Current I is equal to Q by T. That is Ne by T. Number of electrons per second. Electron revolving around the nucleus, number of electrons per second. That is called frequency. That is given. E 1.6 10 power minus 19. So B will be 4 pi into 10 power minus 7. I is Ne by T. That is frequency value 6.8 into 10 power 15 hertz into E. n by t number of electrons per revolving per second. That is called frequency into 1.6 10 power minus 19 by 2r. R is 5.11 into 10 power minus 11. Rearrange and calculate, you are getting the answer 13.4 Tesla. 13.4 Tesla. Okay, right. Fourth problem. Consider tightly wound 100-turn coil of radius 10 centimeter carrying a current of 1 ampere. What is the magnitude of magnetic field at the center of the coil? Wound on a 100-turn coil. So same formula with the number of turns we have to write. B is equal to mu naught Ni by 2R. 4 pi into 10 power minus 7. 100 turns into current 1 ampere divided by 2 into radius is 10 centimeter, 10 into 10 power minus 2. Calculate, you are getting 2 pi into 10 power minus 4 Tesla. That is 6.28 into 10 power minus 4 Tesla. Magnetic field at a point at the center for number of turns concept. Fifth problem. Circular coil has 35 turns on mean radius of 4 centimeter. It carries a current of 1.2 ampere. Find the magnetic field at a point along the axis of the coil at a distance of 40 centimeter from the center. At a distance of 40 centimeter from the center. So circular coil along the axis, B is equal to mu naught Ni A square by 2 into A square plus X square whole power 3 by 2. Basic formula 4 pi into 10 power minus 7. Number of turns 35 turns. Current given is 1.2 ampere. Radius 4 centimeter. 4 into 10 power minus 2 the whole square by 2 into A square plus X square. That is 4 square plus distance is 40 square. 3 by 2. Centimeter is given. Centimeter is 10 power minus 2. Whole power 3 by 2. 10 power minus 6 by 2. 10 power minus 3. Simplify, you are getting 6.5 into 10 power minus 7 Tesla. Magnetic induction at a point along the axis of a circular coil carrying current. Then sixth one, solenoid coil of 300 turns is carrying a current of 5 ampere. Length of the solenoid is 0.5 meter and has a radius of 1 centimeter. Find the magnitude of magnetic field inside the solenoid. We have seen the formula for long solenoid carrying current. What is the magnetic field? B is equal to mu naught Ni. 4 pi into 10 power minus 7, where number of turns per unit length. Number of turns per unit length itself is given. What is the value? 300 turns. Current 5 ampere. Simply multiply. Straight problem. That is 1.9 into 10 power minus 3 Tesla. Solenoid carrying current, magnetic induction inside the solenoid. Seventh one, solenoid of length 0.5 meter has a radius of 1 centimeter and is made up of 500 turns. It carries a current of 5 ampere. What is the magnitude of magnetic field inside the solenoid? Same concept, but number of turns separately given, length separately given. So you have to write number of turns per unit length, that you have to calculate. N is equal to N by L. What is number of turns, ma? In the case of long solenoid carrying current, 500 turns, 0.5 meter, 1 by 2. So 1000 turns per meter. Therefore, B is equal to mu naught Ni 4 pi into 10 power minus 7 into 1000. Current is 5 ampere. So the value of B will be 6.28 into 10 power minus 3 Tesla. Correct? Okay. Eighth problem. Magnetic field at the center of 50 centimeter long solenoid is 4 into 10 power minus 2 Tesla when a current of 8 ampere flows through it. What is the number of turns in the solenoid? Same formula. B is equal to mu naught Ni. But here mu naught capital Ni by L. This is number of turns per unit length. Number of turns only asked. So N will be PL by mu naught I. Magnetic induction 4 into 10 power minus 2. Length given as 50 centimeter. 50 into 10 power minus 2 by 4 pi into 10 power minus 7. Current given here only 8 ampere. That is 1990 turns. 1990 turns. Ninth one. Solenoid of 2 meter long, 3 centimeter in diameter. It has 5 layers of winding of 1000 turns each. Carries a current of 5 ampere. What is the magnetic field at the center? 5 layers. N will be number of turns per unit length, but one layer only generally we are doing. Here we have given 5 layers. So 5 into N by L. 5 into number of turns given 1000 turns. Length given as 2 meters. Therefore, question is B. B is equal to mu naught Ni. 4 pi into 10 power minus 7. 5000 by 2. 2500. Into the current given here is 5 ampere. Multiply, the final answer is 1.57 into 10 power minus 2 Tesla. 1.57 into 10 power minus 2 Tesla. Okay, fine. Next, 10th problem. Proton enters a strong magnetic field of flux density 2.5 Tesla with a velocity of 1.5 into 10 power 7 meters per second at an angle of 30 degree with the field. Find the force on proton. Single charge, that is known as magnetic Lorentz force. F is equal to BQV sin theta. Straight. What is B given? B is 2.5. 2.5 into 1.6, 10 power minus 19. Velocity is 1.5 into 10 power 7. 2.5 Tesla then charge 1.6 10 power minus 19, then velocity 1.5 10 power 7, sin 30. Rearrange, you will get 3 into 10 power minus 12 meter. State substitution mark 11. Electron is moving northwards with a velocity of 10 power 7 meter per second in a magnetic field of 3 Tesla directed eastwards. Calculate the instantaneous force. North, east. So theta is 90. That's all we need. F is equal to BQV sin 90. 3 Tesla, charge of an electron 1.6 10 power minus 19. Then velocity 10 power 7 sin 90 is 1.8 into 10 power minus 12. 3 into 1.6. So 4.8 10 power minus 12. Next, 12th problem. Electron entering a magnetic field of 10 power minus 2 Tesla with a velocity of 10 power 7 meter per second describes a circle of radius 6 into 10 power minus 3 meter. Calculate E by M. Circular path, so BEV, magnetic field force. Circular path, so centripetal force. MV square by R. E by M we have to calculate. One V get cancelled. So V by VR. What is velocity? 10 power 7. Magnetic field is 6 into 10 power minus 3 into the radius 10 power minus 2. Rearrange, you are getting 1.67 10 power 11 coulombs per kilogram. Generally, specific charge of an electron, Thomson's method, the final answer is 1.76 into 10 power 11 coulombs per kilogram. Here we are getting 1.67. For the given data, we are working. That's all. 13. Particle having a charge of 100 microcoulomb, mass 10 milligram, is projected in a uniform magnetic field of 25 millitesla with a speed of 10 meter per second in the direction perpendicular to the field. What will be the period of revolution? Cyclotron, we have calculated time period of revolution for a charged particle moving in a cyclotron. T is equal to 2 pi m by bq. 2 pi, mass 10 milligram. Milli is 10 power minus 3. Gram is another 10 power minus 3. So it will become 10 power minus 6. By B value 25 millitesla 10 power minus 3 into the charge 100 microcoulomb. Charge is given here. 100 microcoulomb. The answer is 25 seconds. Rearrange, you are getting the answer 25 seconds. 14th problem. Protons are accelerated by a cyclotron when a magnetic field of 2 Tesla is applied perpendicular to the plane of the D. Calculate the energy of proton in MeV if the circular path of proton of radius 40 centimeter before it leaves the cyclotron. You have to calculate energy. Kinetic energy, we have calculated. Kinetic energy of a proton which is coming out, BQR, the whole square by 2m. B square, of course, Q square, R square by 2m. 2 Tesla, 2 square, Q, charge of an electron, 1.6 10 power minus 19 the whole square. The radius is 40 centimeter, that is 0.4 meter by 2m. Mass of the electron, 9.1 10 power minus 21, minus 31. Question given here is proton. So proton mass you have to substitute. Charge is same that of an electron, 1.67 10 power minus 27. The kinetic energy is 30.6 MeV because they are asking you to calculate only in million electron volt. 1 million means 10 power 6. 1 electron volt means 1.6 10 power minus 19 joule. That is only actually SI unit. But the question to be asked, answer is in terms of MeV you have to calculate. So we have written like that. 15th problem. What is the magnitude of force on a unit force on a wire of length 0.04 meter placed inside a solenoid near its center, making an angle 30 degrees with its axis? Wire carries a current of 12 ampere. Magnetic field due to the solenoid is of magnitude 0.25 Tesla. Straight formula, ma? F is equal to BIL sin theta. What is B? 12 Tesla. No, B is 0.25. Current 12 ampere. Length 25 centimeter. No. The length given as 0.40 centimeter, 0.04 meter into 30 degree, sin 30. Straight formula, ma? Answer is 0.06 Newton. Straight substitution. 16th problem. Conductor of length 10 centimeter is placed perpendicular to uniform magnetic field of strength 100 oersted. If a charge of 5 coulomb passes through it in 5 seconds, find the force. F is equal to BIL sin theta. B into I is Q by T given. L sin theta. What is magnetic induction? 100 oersted. 100 into, you have to convert into Tesla. So multiply by 10 power minus 4 into charge 5 coulomb 5 second. So 5 by 5. 1 ampere current. Length given as 10 centimeter, 10 into 10 power minus 2 into maximum sin 90. Simplify, you are getting 10 power minus 3. This is 100, 10 is 10 power 3, 10 power minus 6. 10 power 3, 10 power minus 6 is 10 power minus 3. This is 16th problem. 17. Maximum torque on a coil of effective area 0.04 meter square is 4 into 10 power minus 8 Newton meter when the current in it is 100 microampere. Find the magnetic induction. Maximum torque tau max is equal to NBIA sin theta. Maximum means theta is 90. You have to calculate B. So tau max by NIA. What is maximum value? Given 4 into 10 power minus 8 by number of turns. 1 into 1 turn. Current is 10 power minus 4 ampere. Area is 0.04 meter square. That is 10 power minus 2 Tesla or 10 power minus 2 Weber per meter square. Okay. 18th problem. Last one. An ammeter of resistance 0.8 ohm can measure current up to 1 ampere. What must be the shunt resistance to enable the ammeter to measure current up to 5 ampere? Then what is the effective resistance or combined resistance of ammeter and the shunt? Conversion of galvanometer to ammeter, basic formula, S is equal to Ig by I minus Ig into G. You can very well write here as RS. You can very well write here as RG. Resistance of the galvanometer, resistance of the shunt. The given value 1 ampere galvanometer, maximum current 5 ampere. Galvanometer resistance given is 0.8 ohms. 0.8 by 4, 0.2 ohms. Connected in parallel with the galvanometer. Connected in parallel. That you have to mention. Then they are asking you to calculate the effective resistance. Parallel combination only both cases. So 1 by RP is equal to 1 by S plus 1 by G. This is 1 by 0.2 and the galvanometer resistance is 0.8. 0.2, 0.8. Rearrange, calculate 1 by RP first we calculate, then final answer 0.160. State problem. Correct? So these are the basic formulae and problems in the chapter magnetic effects of current. Thank you. We'll continue.